is our first lesson in Chapter 11 on probability and statistics. Our first lesson, 11.1, talks to us about calculating permutations and combinations, which is nothing more than a way of calculating all the possible ways things can happen. One of the ways in which we can do that is called the multiplication counting principle. So what I'd like to have you do is take a look at problem number 1 that's in front of you on your notes, read through it carefully, and see if you can count how many different ways we can purchase toothpaste. So take a moment and see if you can count, and then as you can see, for your convenience, we have a tree diagram to help you with that. So I'll hit pause here and let you do that. Welcome back, and hopefully you came up with a solution, but let's read through the problem together and see if we can come up with the total number of ways of buying this toothpaste that's on the market. A company markets toothpaste in 3 flavors, plain, mint, and cool gel. 2 flavors, regular, tartar control, and 4 sizes, small, medium, large, and extra large. How many ways can you buy toothpaste? What you see in front of you in your notes is called a tree diagram. Sometimes in probability, we make tree diagrams to represent all the possible ways in which things can happen. For example, we could get plain toothpaste with a regular type of toothpaste in a small quantity. As you can see, that's one option. Or we could buy a mint for tartar control in a large option. So you can see there's all these different paths we can take. When you counted these up, hopefully you counted all the different paths, but the easiest way that I know to figure out all the different ways in which to count this is called the multiplication counting principle. And what you do with that is you simply count how many different brands or types of toothpaste do we have here, which is 3. There's also regular or for tartar control, there's 2 there. And then there's 4 sizes. And all you would have to do is multiply those values together to get your total number of ways in which to buy toothpaste. 3 times 2 times 4, of course, is 24. So we have 24 options for us to purchase toothpaste. Again, you can do that by counting how many are in each category and then multiplying them together, or you can just actually make a tree diagram and count all the different ways and routes in which we can take. Another example of the basic counting principle would be a lock. Your lock has 4 digits from 0 to 9 that you can pick from. How many possible combinations are possible if the digits can be repeated? So what we have here is a lock that has the digits from 0 to 9 on each. So I'll just put little windows here to help us represent each one of these. We're looking for all the possible combinations that we can acquire here. Now the first thing we got to ask, the first question we have to ask ourselves is this: how many different digits can I select from if I can pick from 0 to 9? Well, that gives us a total of 10 digits for each. So then basically we have 10 for the first window, 10 numbers for the second, because they say initially we can repeat them, so we could have the same digits appear. 10 for the third and 10 for the fourth, which of course is 10 to the 4th power, which is 10,000. So if you have a lock with 4 digits for each digit, and you can pick from 0 to 9, so you have 10 options for each. You have 10,000 different ways to represent your combination. If you cannot repeat the combination, then this is how that changes things. We have 10 options for the first dial, but now we only have 9 options for the second dial. And the reason being is if let's say we select a number, for example, 4. We cannot use 4 in the second location. Now if we pick 2 numbers, then of course there's going to be only 8 options for the third and 7 options for the fourth. So your combinations, to answer this last question, if the digits cannot be repeated, how many possible combinations would we have? Would simply be calculated by multiplying 10 times 9 times 8 times 7, which in turn would give you 5,040 combinations or possible combinations. So you can see instead of by limiting to not repeating digits, we all of a sudden now have about half as many selections we can pick for our combination. Now, in this particular chapter, the first lesson, we also have what we call a permutation. And what I'm going to do first is define it and then give you an example of what a permutation measures. The definition is right here. A permutation is an arrangement of items in a particular order. Right here, you see the explanation point next to the 3. That's read as 3 factorial. What it means is we take 3 times all the numbers that are 3 times 2 times 1, which will give you 6. So if this were 4 factorial, you would say 4 times 3 times 2 times 1. Or 10 factorial would be 10 times 9 times 8, all the way down to 1. What this measures is how many ways 3 things can be arranged in a specific order. For example, if we have 3 books on the shelf, and we want to know how many ways we can arrange them, that would be 3 factorial, which of course we already calculated to be 6. So permutation measures a specific order in which things can be arranged. So remember that. P, or permutation, order matters. Now we get into more specific types of questions. And this one will actually, I think, be clear as I read through the definition. Basically, if we have the number of permutations of n items of a set arranged r items at a time, this is a formula we're going to use when we pick a group from a large group, and the order that we select this small group from the larger group does matter. So let's take a look at our example here, and I think that's going to help you understand this. 10 students are in a race. First, second, third places win medals. In how many ways can 10 runners finish first, second, third, assuming no ties? What we're going to do here is count how many ways we can select a group of 3 and give out first, second, and third place from this group of 10. The first thing we have to do is calculate our n. This n represents all the people that are in our set. So what we're going to do is put 10 first, and then we're going to put P. P stands for permutation, and it does represent where order matters. R represents how many prizes we're giving away. In this case, we're giving away 3 prizes, so R is 3. If we were just giving away 2 prizes, then it would be 2. If we were giving away 5 prizes, it would be 5, etc. Now I'm going to show you how to do this by hand, and then I'm going to demonstrate to you how to use your calculator to work this out. So what we got here is 10p3. So we're going to put 10 factorial on top, which is what the formula tells us to do, take n factorial. And then on the bottom, we're going to take 10 minus 3 factorial, which is exactly what it's telling us to do. Now, if we simplify, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5, all the way down to 1. That pattern continues till we get to 1. Then we have 7 factorial, starts at 7, and then goes all the way down to 1. Since these are all factors, the numbers 7 on down can be canceled out, leaving you with 10 times 9 times 8, which is 720. So we have 720 different ways to pick 3 people and give them medals from a group of 10. Now what I'd like to have you do is pull out your calculator, TID 3s. I'm going to put this up on the smartboard, and then I'm going to show you how to do some of these calculations on your calculator. So I'm going to hit pause while you get set up with your calculator. Okay, welcome back. As you can see in front of you, you see a TID 4+. I'll demonstrate first to you how to calculate a factorial. You know, the problem that I gave you was arranging 3 factorial, which is 3 times 2 times 1. We could do that by hand, but let's do it with a calculator because you're going to end up having some very large numbers if the number gets larger. So let's put 3 in. What you do then is you go to your math button and go to PRB. PRB is the probability, and then you can see there's a factorial key there. So enter that, and it pops up next to your 3, and then it will actually do the 3 times 2 times 1 for you. This is extremely helpful when we get into like problems that have 10 factorial or even higher. It gets the numbers get dramatically larger. So there's one way of calculating a factorial with your calculator. If we do the where we're giving out first, second, third place I'll show you there's an option there also. We would first take the number of people we select from, which is 10. Then you go to the math, go to prob, and you can see it's right there, NPR. So you got to go down to NPR, enter, and then we're going to give out 3 places. So 3 comes after that, and you can see we come up with our 720 options there. So a couple handy things that we can do with our calculator to help eliminate tedious multiplication. So hopefully this part 1 went well. Part 2 will be coming up. Hopefully, let me know if you have any questions about part 1, and proceed on to part 2.